video, I will make habitat suitability models for a critically endangered coldwater coral in the Mallorca channel. So welcome everyone. My presentation will be a classical one, starting with an introduction on the biology and ecology of the species. Then I will go into the threats the species is facing, how habitat suitability modeling can actually be useful in the deep sea. Then I will talk a bit about the study area and the research questions I pose. Then I will talk about the data sources I use for modeling, the retained variables, and finally the algorithms that will be used. Then the response curves will be discussed, the modeling predictions, and finally I will also propose an area that could be protected as a theoretical exercise. And finally, also some limitations of the study. And then I will conclude with a conclusion and some future research. So Isidella elongata is a coldwater coral of the Isidella family, or the bamboo corals. It lives on compact mud plains between 200 and 1,800 meters depth, so it's quite a broad depth range. It is a rigid and slow-growing species. It grows about 1.4 centimeters per year, and it's often associated with diverse fauna. So you can see already the species here in the background, but I have also some nice images of this diverse fauna. So here you can see all different species that were found close to these Isidella elongata colonies. You can see an anemone here. You can see 2 species of fish and also a lobster. But there is many more, just to show some of this diversity. We also have some video footage, which is always nice to show. So this was taken by an ROV, so underwater robot, kind of remotely operated vehicle. And here there's this fish that is trying to camouflage itself versus the Isidella elongata colonies. It's very nice to see. And then in the next one, you can see actually a colony of Isidella with a crab on top, and this crab is trying to capture prey. So this is just to show the diversity, but there is also an association of this species with a highly valued red shrimp called Aristeus antenatus. And this is the target of a large bottom fleet in the Mediterranean Sea. Which is bad for Isidella elongata since it's very sensitive to trawling. On the left here you can see a picture of healthy colonies found in an area where trawling is very limited, while on the right you can see a damaged colony in an area where there's a lot of trawling, and you can even see some traces of this trawling on the picture. Here there is 2 marks. In the 1960s, Isidella was present over the entire Mediterranean Sea. But now it is critically endangered, as assessed by IUCN Red List. As you can see also on their website, it's critically endangered, 1 step before extinction in the wild. So it's quite bad. It was taken up in the Barcelona Convention in the 2nd annex of endangered and threatened species. And this urges parties of this convention to set activity to protect the species. But of course, first you need to know where the species is. And this is the currently known distribution of Isidella in the Mediterranean Sea. Here, this circle denotes the study area. But to also, of course, to delineate protected areas, you need a finer scale distribution of the species. And this is where modeling comes in. So habitat suitability modeling is often done in the deep sea because observations are very difficult and costly. Because you can't simply go there by diving, you need specialized equipment. And hence they are limited. And then habitat suitability modeling is an important tool to assess the distribution patterns. A kind of definition is to relate species observations with environmental predictor variables in order to predict if the habitat surrounding these observations is suitable or not for the species. We will make these models, and this is the study area. So it's situated near the Balearic Islands, in between Mallorca, Ibiza, and Formentera, which is also called the Mallorca Channel. You can see here in red the study area. There's also some submarine electricity cables that are running through the study area, and there's also 2 seamounts present here and here, called Ses Olives and Ossias March. Actually, this study site is very interesting since the colonies that were found here are the most currently known, the currently most dense colonies, most dense population that is known over the entire Mediterranean Sea. So it's a very interesting study site. The research questions that I will pose are what are the most suitable environmental conditions for Isidella elongata, and where are these conditions present in the Mallorca channel, or in our study area more specifically. So to do modeling, you need data sources. The sources I used were occurrence data of Isidella elongata. Then we also have bathymetry, so the depth. And then finally, we also have water column data about temperature, salinity, oxygen, and turbulence, and fishing data of the bottom trawlers. Of the latter two, I did a lot of processing of this data. We started with some point observations, and I interpolated them, cleaned the data, and made maps out of these. But unfortunately, we couldn't use them for modeling since our spatial resolution was very coarse compared to the occurrences of Isidella elongata. As you can also see here, so this is the water column data interpolated between 400 and 600 meters depth. And you can see temperature, salinity, turbidity, and oxygen. So you can also see the presence-absence data of Isidella elongata, which is very, very close to each other, while the variation at this level of these variables is so low, it's close to the detection limit, that we actually couldn't include this in our models. So finally, we use the bathymetric variables, and we derive different variables from these. So this is what the model will look like. It's the presence-absence of Isidella compared with these bathymetric variables. And the first one is the BPI, so the bathymetric positioning index. I made a little sketch here, and you can, so the BPI is actually the elevation of the pixel in its surroundings. So if it's lower than the surroundings, it will have a negative BPI. If it's higher, it's a positive BPI. We calculated this on two scales. We have two of this variable. Then there's also roughness. Roughness is close to 0 when the area is flat, while if the area is very sloped or highly irregular, it has a high roughness value. And then finally, we also have the aspect, so northness and eastness, which is the orientation of a pixel towards a certain direction. So in total, we had 5 variables. And then we used 3 different modeling algorithms called GAM, Maxent, and random forest. To be very short about this, because I can't go into details. GAM and Maxent are a kind of regression between the predictor variables and the response variable, which makes a kind of these curves in different forms and formats. While random forest is a classification-based algorithm that uses this decision trees, as seen here on the right, and has a higher performance, but is less easy to link with the biology because it doesn't have these nice curves. And then we combine these into one ensemble model that combines a prediction of all of these, and is thought to have higher accuracy than each model separately. So these are already the results. These are response curves, so this gives the relation between each predictor variable and the probability of presence of Isidella elongata. I will focus mainly on the 2 important ones because the models each give an importance to each variable, and the most important ones were broad scale BPI and roughness. I made a little sketch to make this more comprehensible. So broad scale BPI on the right, high values of this parameter give low probability of presence. So the species, the habitat is unsuitable when areas are elevated, which can be seen here on the sketch. Then for roughness, 2 out of the 3 models show that low roughness values are preferable, while Maxent didn't have this distinct pattern. But 2 out of the 3 models say that low roughness values are best, which means that they do not like to be on irregular areas or on slopey areas. This can also be related with the numerous sightings of this species in the Mediterranean Sea on the deep, flat and smooth mud plains. And then finally, these are the predictions within the study area. So we had 3 models, so 3 predictions, but we combined this in an ensemble model, and I will talk about this more in detail. So this is what it looks like. I made this in 3D to show the bathymetry better. So first and for all, in red, you can see that the probability of presence of Isidella elongata is high, while in blue, the probability of presence is low. And then if you look at this in 3D, you can actually see that the low probability of presence is present on top of the seamounts in the area, while probability of presence is higher surrounding these seamounts, but also in between them in distinct patches. So these were the main conclusions. And then this is again the same, close to Ibiza and Formentera, the study area again. And then we tried to propose an area that could be protected just as a theoretical exercise. This is an area that is already protected above Ocea's march. And we proposed to expand this area to also include this surrounding area and also include Ses Olives and this part where habitat is also suitable. And then you get something like this, which we also connected with a corridor that should increase the resilience of the populations. Finally, we also have some limitations of the study. So we couldn't include fishing efforts, which is unfortunate, and we think that this might have this could have a high impact on Isidella in the study area, since the densities of the colonies is very high, and we made a simple calculation with a regular haul. And this regular haul of about 2 hours could affect 6,000 to 7,000 colonies, destroying them or completely removing them. So it could be quite bad. And finally, we couldn't include them because a lot of these observations of presence absences were present in pixels where there was 0 fishing effort per day. So there was not enough variability to include these also in the models. And then we come to the conclusions. So what did we learn is that the most suitable habitat for Isidella elongata is smooth, flat, and non-elevated areas. And this was present in the study area in between and surrounding the 2 seamounts called Ses Olives and Ocea's March. And then finally, we also made some suggestions for future research. So in the models, additional fish predictor variables could be included, such as fishing efforts, but also currents, which is very important for cold water corals. But we couldn't include these because models weren't detailed enough in the area. And then also the water column data would be interesting to include into the models. Then the biology and ecology of Isidella elongata is still largely unknown. So there is almost nothing known about reproduction, dispersal, and feeding ecology. So it's a very interesting site to study this, because of the high densities of colonies that were found in this area. And then finally, the making of habitat suitability models on a larger scale in the Mediterranean Sea would be nice to also find other areas that are this interesting, and maybe to protect these areas where these critically endangered species could still be present. And then finally, I want to thank everyone that helped me with this project. Without them, I couldn't have gotten anywhere. So thanks a lot, especially to my supervisors, Patricia Kova and Francesco, but also to the people that helped me with the modeling, that helped me with the acquisition of the data, the interpretation of the modeling. Thanks a ton. And so this was my presentation. If there's any questions, go ahead.